What we have in front of us is a coronal slab through roughly the center of the forebrain. And I want us to examine the features that we find deep within the brain. On the outer surface, we have the cerebral cortex, which is just a few millimeters of gray matter thick. And then beneath the cerebral cortex, we have white matter. And that white matter runs in various directions throughout the hemisphere. There are some special white matter structures, such as the corpus callosum, that are obvious in this section. And then there's one that's not quite so obvious, but it's worth pointing out, and it's called the internal capsule. The internal capsule is a band of white matter that allows the cerebral cortex to send axons to the diencephalon in the brainstem and spinal cord below it, as well as for structures like the thalamus and certain cell groups in the brainstem to send axons up to the cerebral cortex. For our purposes here, the internal capsule is a landmark that helps us orient the rest of the deep gray matter visible in this section. On the medial side of this deep gray matter, we have a structure called the caudate nucleus. And the caudate nucleus is part of the basal ganglia. The caudate nucleus sits just medially to the internal capsule, and it forms the lateral wall of the lateral ventricle. Now, just on the lateral side of the internal capsule is another bit of gray matter that's very similar to the caudate. Its name is the putamen. So the putamen is this bit of gray matter that sits out here lateral to the internal capsule. Now, there's a triangular region between the putamen and the internal capsule that is yet another deep gray matter structure, a different part of the basal ganglia that we call the globus pallidus. There are actually two parts to the globus pallidus. This pin is currently in the internal segment of the globus pallidus, and just on the outer side of that pin is what we call the external segment. Now, these three deep gray matter structures are principal components of the basal ganglia, and it's important to know their relations one to the another and to the internal capsule. Also in this view, not in the basal ganglia, but down here in the anterior part of the temporal lobe, is the amygdala. The amygdala is a large mass of gray matter found in the anterior medial temporal lobe, just in front of the hippocampus. And the amygdala is very much involved in alerting the rest of the brain to situations that might potentially be threatening or otherwise alarming. Meanwhile, these structures that we've pinned here, the basal ganglia surrounding the internal capsule, these are structures that are all about movement. So now what we have in front of us is another coronal slab taken just about a centimeter in front of the first slab that we were looking at. And again, I want to highlight the internal capsule, which is this band of white matter that helps us orient ourselves relative to the gray matter that surrounds it. And on the medial side of the internal capsule is the caudate nucleus, forming the lateral wall of the lateral ventricle. And on the lateral aspect of the internal capsule is the putamen. Now, in this slice, we don't have the globus pallidus because the globus pallidus is a structure that we only see near the middle of the basal ganglia. We're just in the front part of the basal ganglia, and it's worth focusing in this region so that we can highlight a portion of the basal ganglia where the putamen and the caudate nucleus join together just inferior to the internal capsule. This part of the basal ganglia we call the nucleus accumbens, and I've given it a flag with the letter A for nucleus accumbens. Each of these three parts of the basal ganglia, the nucleus accumbens, the putamen, and the caudate, they're all about helping to regulate movement. The putamen is involved with regulating movement of the body, right here. The caudate nucleus is concerned with movements of the eyes, and with movements of the eyes go movements of the mind and of thought. So the caudate nucleus is involved in modulating movements of thought. Down below, the nucleus accumbens is involved with modulating movements of emotion or mood. So we can think of these components of the basal ganglia as all being involved with the modulation of movement. What distinguishes them are their anatomical connections and also the functions upon which they operate. Now this coronal slab in front of us is about 2 centimeters posterior to the last one we just saw. And I want to draw your attention into the anterior and medial part of the temporal lobe. Where 2 centimeters in front we had the amygdala, now we have a structure known as the hippocampus. And the hippocampus is one of those fantastic names in brain anatomy that tell you something about its shape. The hippocampus is so named because of the curvature of the cortex, as this structure folds in upon itself, much like the body of the seahorse. Hippocampus is a Greek word for seahorse. And I think you can appreciate the curving nature of this medial margin of the temporal lobe forming the hippocampus. We see it nicely on both sides, forming the medial edge of the temporal lobe, and also forming the medial wall of a bit of the temporal horn of the lateral ventricle. So the hippocampus protrudes towards the lateral ventricle from the medial edge. Now what we have in front of us is an axial slab from a different brain, and we want to look again and find the same set of structures, the internal capsule, components of the basal ganglia, and the hippocampus. Now let's begin with the internal capsule. From this perspective, the internal capsule makes a bit of a chevron shape in the brain. We can speak of an anterior limb to the internal capsule and a posterior limb of the internal capsule. Now let's look at the anterior limb of the internal capsule. We can identify it again with a little flag, just to hold your attention on this bit of white matter. On the medial side of that internal capsule, we have the caudate nucleus, which, as you can see in this plane, forms the lateral wall of the lateral ventricle. So this space we see here, this is the lateral ventricle, and note how the caudate nucleus is protruding out into it. On the lateral aspect of the internal capsule, we have the putamen. So there is our putamen. And in this specimen, you can probably notice there are multiple little markings here. And these spots probably reflect the consequence of chronic hypertension. The small black dots you see are blood vessels cut in cross-section, and the whitish spots around them are probably some scar tissue that has been laid down by activated astrocytes. And these spots represent the consequence of having tiny blood vessels pulsate under elevated mean arterial pressures for an extended period of time. And you can think of these as local regions of microtrauma deep in the tissue. Now, just medial to the putamen, but still lateral to the internal capsule, we have the globus pallidus. So there's our globus pallidus in this specimen, with the boundary between the putamen and the globus pallidus being visible right along this margin right there. So we have putamen lateral to that margin, and then globus pallidus on the medial side. Now also in this tissue section, we have a nice look at the hippocampus. So here again is the hippocampus, which is on the medial edge of the temporal lobe as this cortex wraps around itself into the shape like the body of a seahorse.